Hello people, welcome back to my channel as I take you on another geospatial and data visualization journey with R. This time I'm going to show you how you can utilize the STAC API, tap into the Microsoft Planetary computer catalog, and then download one of its data collections from the ESA Global Land Cover dataset and create some crisp land cover maps with R. Alright guys, welcome back to R, where we will first of all install and then load the packages that we need. For that purpose, we'll be using Pacman library. And if you don't have Pacman installed on your system, I suggest that you install it, and you can simply use install packages, put double quotation marks around it, and then you just run this. Then once you install Pacman, you can call one of the functions from Pacman, which is called pload, which helps you load the packages, and if you don't have them, first installing. The first one that we will need is the RStack package, which is a client library for communicating with Stack, and then through that we'll be working with one of the catalogs, one of many, and that is the Microsoft Planetary Computer API for Stack, which has more than 100 data sets. So this package is going to come pretty much in handy in this tutorial. The second package that we need is the asset package, because we will be working here with city boundaries. And to get city boundaries, we'll be using again ArcGIS layers package, which helps us connect to the ArcGIS REST API and then fetch one of its rich datasets. Then, of course, our main target into this tutorial is the European Space Agency Global Land Cover dataset, which comes from this Microsoft Planetary Computer API. And to work with rasters, we need, for that purpose, Terra. Now, we also want to make sure that this file which we download, and this is the land cover, which is quite crisp, it's 10 meters resolution. We want also to make sure that we resample it so that it gets a small resolution. And for that purpose, we'll be using elevator package to get the relief data and then use it as a layer for resampling. Of course, we also want to visualize in this tutorial, so we will need to use ggplot2 from Tidyverse, which is the umbrella package. And then last but not least, I will also be using tidyterra for an easy plotting of a global land cover. So we'll be downloading the global land cover, but for a very small area, because I just want to showcase you how you can do that. And because of that, we will be using city boundaries, which are quite small. And in one of the previous tutorials, we also used that. So I'm actually just here pasting the link from that tutorial, but you can check it out if you're interested how we did it and where you can find this data on the ArcGIS REST API. For now, I'm going to convert this to a string and then use this to actually fetch the data directly into R. I'm going to call this city data. And then, as we did also in the previous tutorial, I'm going to use ArcGIS layers and arc open. So basically to open the connection with this source, with this URL. And once we open the source, then we can actually get the simple features objects or SF object, again, using here ArcGIS layers. And then this time the function which is called arcselect, which helps you actually select the features that you need. So over here we'll be using city data. This is our main query, and then we can also narrow down to the fields that we need. And one of the fields is the name of the city. Name of the city, and then here you can also write a filter, which is the where command. And here you can basically write that the name should be equal to. And then over here, what we will be using in today's tutorial is the extent of Sao Paulo in Brazil. So I'm just going to put it here. You can also check this data set and its map, and you can see what are the actual city boundaries that it supports, so you can take for some other cities across the world. So for now, we're just going to be taking this one. And you also want to specify here the coordinates reference system, or CRS, and you also want to take here the standard 4326 datum of the WGS84 coordinates reference system. I'm really excited to introduce you to the Spatial Temporal Asset Catalog, or STAC index, which we will be tapping into in today's tutorial. You can find it at stackindex.org, which I'm also going to provide in the description box below. So why are we here? Because this website is actually hosting a bunch of very interesting catalogs. One of them we'll be using here. So if you want to explore it, you first of all go to this website, and then over here you can click on this catalogs tab, which is going to open you all the existing ones. You can of course filter here those that are using APIs and public only, and then you can actually scroll here and see what is offered. So the one of them that we will be using is called the Microsoft Planetary Computer STAC API, which also offers a bunch of spatial temporal metadata and data, and in essence it includes more than 100. So I think 123 or something like that. Anyways, so this is actually the link to this Microsoft Planetary Computer Stack API, which you should right now actually copy, because we will afterwards paste it into R and use it to actually communicate with this API and get the data we need. For now, we just want to explore what this has. So we can just click on this link, Microsoft Planetary Computer Stack API. This is going to open the new window with all the possible collections, where actually collections are, of course, data sets. You can even organize them here in a certain order if you want. And then what you can do is you can see here the identifier. So this identifier we'll be using in R to download the data set itself. And you can see here the title, which is more a user-friendly format where you can understand what is actually offered here. Now, what you can do here is the following. You can actually go ahead and search for one of the datasets, and one of them that I wanted to use in today's tutorial, and that some of you also suggested, is this ESA WorldCover dataset. So this one. Now, to see this dataset, if you're not familiar with it, you can just simply click on this link, and this is going to open the page for this collection. All right, and this is going to also show you what is the link to this collection. It is going to give you a short info about it. So this is coming from the European Space Agency work. It's available for 2020 and 2021. So there are actually two rasters at 10-meter resolution, so it's pretty crisp. And it's based on Sentinel-1 and Sentinel-2 imagery. For us, what is important, this is in the Cloud GeoTIFF format. And here you can also access user manual for each of them. Because you're interested in 2021, you can actually open this manual by clicking on this first link, which is called WorldCover 2021 version 200 user manual. So this is going to open then a new window here, or more precisely a PDF, which is contains all the information about this data. So you can scroll down. Then on page 3, you can see here of course, the description of the content. And one of the things that you want to click on is this map land cover classification on page 14. Basically, this is going to offer you here the codebook. So this is the codebook, all the classes, what they mean, also their colors, and basically what you have here is going to be included also in the raster. Well, not completely. So the map code is definitely going to be there. It goes from 10 to 100 with increments of 10, except for mangroves, which are 95. And these are also the colors. So the colors are also going to be part of our raster as a part of the color table. What we won't have is the land cover class label, but this is something that we're just going to copy and paste into R, and I'm going to show you how we can utilize it further. Anyways, going back to this web page where we had information about this ESA WorldCover dataset, on the left-hand side, you can see some metadata information. So it's available for the entire globe. And then there is this temporal extent. This temporal extent is going to be very important for us, because what we want to get out of this one is we want to get information for 2021. So we will need to remember here that this goes from 1st of January at 1 a.m. and then it goes all the way to the end of that specific year. So here you can also find more information about it, how this was created, who are the providers, and also the product version. And also here you can see a thumbnail with the dataset, how it looks like for a certain extent. Of course, you can also see some additional tabs here, which will be actually important once we start importing the data. One of them is items. This simply shows you how, what is the name of some of the sample files here. So they have, all of them have this ESA _WorldCover, which is basically simply shows you what is the name of the dataset, and this 10 meters 2021 indicating the year and also the version, and finally the name of the tile. So that's for the items. For the thumbnail, so this is basically just the one that we saw at the beginning. And then for the assets here, you can download, of course, these thumbnails and information, or actually the tiles, which are stored in Parquet format. And there are also some links here, and one of them that we already accessed is this product version user manual for 2021, which was quite useful to understand. Anyways, if you want to know more information about it, I suggest going back to the manual. And there is also the validation report for both versions, for 2020 and for 2021, which you can also access. But for now, the most important thing for us is that you copied that link, this actual link, to the Microsoft Planetary Computer API, which we will then paste into R and create a query based on it, and then fetch, download the data directly onto our local drive. All right, we are back in R, and I just pasted here that a link to the Microsoft Planetary Computer API. So what we're going to do next is simply convert this into a string, and then we're going to be using the RStack package. So from RStack, we'll be using the stack function, which helps us actually build the query and parameters for essentially accessing the data for this API. We're gonna just call this MS query, for example. MS is just a shorthand for Microsoft, because we will be fetching eventually the data from the Microsoft Planetary Computer. And then once you actually do that, and the output is not going to be that interesting, it's just going to be a bunch of parameters that this query has. Now, if you want to actually check what are the collections within this specific catalog, you can also do that. What you actually need to essentially to do is you need to, let's say, create here an object, and then you need to pass into a pipe this created query. And once you do that, you can get from RStack a function which is called collection. So this is gonna, request to get collections, and then to actually get them, to get lists, you need to also send here get request, and this is it. Now, once you actually run this, you will get, especially for this one, this MS collections, if you open it, you will see here that there are 123 collections. And then here it just lists the first few. So if you're interested, how do we find this ESA WorldCover, or ESA to be more precise, you can just go ahead, for example, and you can then print all of these collections. So you can go ahead and say, yeah, I want to print all 123, and you can find. We also previously found on the website that code the way it's called, but if you really want, you can also do that. Anyways, the code is ESA-WorldCover. So it's this one, and we can actually call this one, pass it to this collections object, because we will be using it more than once. And I like to actually create them if I'm using something more than once. Okay, now comes the part where you actually want to search the data availability for this specific collection. All right. And to do that, you can again call or build a query using RStack. Now, this time we'll be using another function, which is called stack search. So this is going to search all the catalogs, or within this specific catalog that we previously specified here, so the Microsoft Planetary Computer. It's going to search for collections with this specific name, ESA WorldCover. All right, so over here, first of all, for the query name, we specify this MS query that we previously created. Then for the collections, we're going to specify the collections objects, which is ESA WorldCover. Then the third one is optional. This is basically ID that you want to input there. But the better way to do that is to use datetime. Now, you remember over there when we were at the website, you could see there what is the range. So this dataset, this WorldCover dataset, has only 2 years. It has 2020 and 2021. But if you want to fetch 2021, you basically need to say that you want this dataset for the range from 1st of January of 2021 until 31st of December 2021. And this is exactly what we're going to write here so that you get only that one, because if you don't specify here the date time, it is going to give you also the 2020 dataset, and this is what we don't want at the moment. So here is how you do it. You first of all here write, again, with timestamps. So 1st of January 2021, and then here you need to put T for timestamp, and then here you need to write hours, minutes, and seconds. So this is gonna be, and then complete here with Z. So this is the first date in this range. Then you need this slash, and then you need to specify the second date. So as we said, 2021, 12th month, and 31st day. And then again, followed by a timestamp. But this one, 23 hours, 59 minutes, and 59 seconds, and then also you complete here with that. So basically this covers the entire period of 2021 for which we want to fetch the dataset. And then finally here, and this is a very cool feature, is that you can get this only, let's say, for a certain area. So you don't need to download everything, otherwise it would be really huge. So what we can do here is we can actually create a bounding box, right, object. So we can just call it bbox. And then our bounding box is going to be based on that city polygons, all right? And to create the bounding box, we can simply use here SF function for creating bounding boxes, and then just pass here cd_SF, all right? And after that, we can just pass here to this argument bbox. So this is going to make sure that we get only and only the data for this bounding box. Of course, this will return a tile, and this tile we then actually need to work with that style, so it's going to be in rectangular form. But if you want, you can also crop it. So this is going to return basically a rectangle around those city polygons of Sao Paulo. And then the final thing here that you want to do is, or one of the final things, you can also use, for example, optionally limit here. So for example, you can, if there are more files, you can put a limit to 100 or even more. So this is totally optional, and this context is not needed because we'll be getting only one file, and that is the tile for 2021. Now, the final thing that you want to do is call again RStack, and then right here, get a request, so that basically you push this to the API. All right. And then once you do that, it's not over, because you need to do one more thing. So there is, you don't need to register to use the service, but you don't need to sign in to the Microsoft Planetary computer. So it's kind of a registered what you are kind of fetching and what you're doing. So it's for monitoring purposes, but you don't need to register officially or even pay anything for the registration. But we need this step because otherwise we won't be able to do anything about it. All right, so in order to do that, we need to create here an object, and I'm just going to call it MS query sign in. And then to sign in is quite easy. So from RStack, you just need to use here items sign in, items sign, or actually item sign. And then within this one, what you need to pass here is that this query that we just wrote, where we put the information on what we need. So that one, and then followed by another command here, which is called sign planetary computer, because we are essentially fetching here the data from the Microsoft Planetary computer. So this is going to do the trick. And once you actually run this, once you run this whole thing, and once you get this MS query sign in, you can actually then inspect what this one entails. This is basically, if you followed all the steps, should show you the name of the file that you want to get. So one of the first elements here is this features, and this is going to tell you the name of it. So the name of it is WorldCover 10 meters 2021 version 2, and then this is of course the name of the file in terms of its coordinates south and west. And there are here some assets. Assets are essentially what you want to download. What is the type that you want to download? It sometimes can be confusing because it doesn't really tell you, okay, what are the TIFF files here that we want? But for one, you will need to use assets, which is called map. this is gonna download the TIFF file that you're looking for. And finally here, what you can see are some of the fields of this item that we will be downloading. Once we have everything in place, we're ready to download the data, again using RStack, and then assets download function. So over here, you need to specify several things. First of all, there is an argument which is called items. So over here, you specify your query. And this last one where actually you sign in, so we can pass it here. The second one is the name of the asset or assets that you want to download. So that's also one important thing. You can specify several. Now, we said that we want just TIFF tiles or TIFF tile. So we want to specify here map. And importantly, this should be specified as a string, just as I did it here. Then for the outputs directory, this is where you want to actually download your data. So what I would like to do here is I'm gonna put this into my current working directory, and that one I'm just gonna call main dir. Okay, so I'm gonna put it here, and then finally this is an optional argument if you already maybe downloaded or not. If you already downloaded, maybe you just want to override those files, so you can also pass this optional argument override equals true. So the data is downloaded to your main working directory, but in the process, several folders and subfolders are created. And here I just wanted to show you the structure of this. So considering, let's say that the root directory is your main working directory, what this actually running and downloading the data has created is another folder, which has the name of this collections, which we used before. Then here, another subfolder, and finally another subfolder. So within this map, finally, you will find the TIFF file. Okay, so what we actually need to do now is we can either manually just specify where this file is and then load it, but I'm actually going to show you how you can create a pathway, how you can build it, and then just pass it to R and load this TIFF file. So first of all, we need one of the elements here. So as I said before, we have this one, it's called collections. This one is, the next one is called a version. So this is the version, which is V200 or V2. The third one is basically year. So I'm just going to pass it as year here. And again, in terms, in the form of a string. And then asset name, which actually maybe we could have also created here, but that's fine now. It's called map. All right. And then once we have this, we can actually create the pathway to the file itself. And I'm going to call that pathway data dir. Of course, I'm going to use paste null from base R, and then I'm going to build on top of our main directory where actually the data lies. All right. Now remember, in R, you always need to put the slash sign, which goes from left to right, okay, in front of every of these objects as you build this pathway. And then you can add one after another. So version first, and then again, followed by, of course, this slash sign, followed by year, so the name of another subfolder. And then finally, we finish with the assets name. Okay, so this is gonna build the main one. I think we just forgot one more, which is collections. So between main dir and version, you need to have also collections here. And again, just slash in between. All right. And then once you actually run this, you will create the pathway. Then you simply need to load the raster file using this pathway. So first of all, what I'm going to do, I'm going to go ahead and list all the files that exist under this pathway, which is called data dir. Of course, it's very important that you also include here full names. And then I'm just going to show you actually what we got here so that you can properly understand what's going on. First of all, let's create data dir. And then once we create data dir, I just want to show you here how it looks like in my example. So for me, this was the main working directory. So what I did, I added here collections name, version name, year name, and then asset name as well. And then if I now want to actually get here what are all the files that exist on this one, I'm just going to run this, and then I'm going to print this raster file. And within this one, you can finally see that it's recognized, and here it is under the same name that we downloaded. All right, but that's not all, because we also need to load this as a raster file Luckily, that's quite easy. So I'm just going to call this a land cover raster, for example, and then we'll be using Terra Rust to load it. We can simply pass here raster file. And once we do that, we will get this entire tile, but we only need the land cover for the extent of Sao Paulo. So we basically need to crop this. And we can use, again, Terra for that. I'm just going to call this city land cover because it's not anymore the entire tile. And then from Terra, we'll be using crop. Now, within crop, what you need to specify are several things. The first one is what you want to crop. So you want to crop this land cover raster. The second one is the polygon that you want to use for cropping. So in our case, this is the city_SF. And you also want to here coerce this into a Terra-friendly vector format. So that's why I'm putting brackets around it and also using this Terra vect function. And then finally, you also want to keep only everything that is just like inside the bounding box boundaries of your city. So you need to specify here that you want to snap or you want to actually clip only what is inside of it. Okay. So once more, this is actually going to return a bounding box, so the land cover for the bounding box of Sao Paulo, not for the borders themselves. If you really want that, you can also achieve that. You simply need to add here the mask equals true. As easy as that. But for now, we're just going to go ahead and use like this. We can also manually enter the borders later on in the ggplot2 code. But if you really want to inspect this one, you can also do that. We can just use the plots from plot function from Terra, and we can pass this city land cover that we just created by running this. And then once you actually run this, you should be able to see the land cover only for the area of Sao Paulo. Here we quickly inspect this newly created raster, and one thing that you can notice are the dimensions. So it's more than 5,000 by more than 10,000 pixels, which is quite a lot. So what I'm going to show you next is how you can resample this so that you can then clearly create a map without your session crashing. Over here you can also find some other things, the extents, the coordinates reference system, and of course, this is telling us that there is already a color table, which you previously saw in the codebook that I opened. And then this is, of course, the name, which simply inherits the name of the tiles. And then the minimum and maximum values, which actually correspond, again, to the values from the codebook. All right, so in order to resample, there are actually two options that you can use. One is you can aggregate this, basically just aggregating the pixels to create a coarser resolution, but if you do that, you will lose those colors that exist currently in your raster. A better way is to simply resample using, let's say, a digital elevation model. And this is what we're going to do because this is going to preserve the colors of your different land cover classes that you have. So I'm going to create this object, and here we actually call elevator, and from elevator we call get raster. So here for the locations we specify that we want for the city SF, and then for the level of detail, because we are working with a very small one, we can go for 11, maybe even 12. If you want, you can really work with this one and see what works for you. And then for the clipping one, we're just going to go for the bounding box. So it's going to return also the bounding box so that we can do a proper resample. And then elevator is still working with the raster, which is deprecated and obsolete. So we need to coerce this one into Terra Rust. All right. And then once you get this, you can go ahead and resample the land cover dataset for Sao Paulo. So I'm just going to call this one city land cover resampled. And then from Terra, we can use option which is called a resample, of course. And then within resample, you need to specify 3 arguments. X is what you want to resample. So we want to resample the city land cover. The Y argument is what you're going to use as a base layer for resampling. So this would be the dam layer. And then the final one is the method that you want to use. So because here we have classes, so we have categorical values, and we would like to preserve them, we need to use the nearest neighbor as the method of analysis. Okay, and then once you actually run both of the code chunks, you can also then plot again and see what you have here. Essentially, you will be seeing the same picture when you plot this, but essentially we decrease the resolution so that you can later on be able to plot with ggplot2. So you notice that the values in the codebook go from 10 to 100 with increments of 10, with one exception of 95 value. And one thing that is worth noting here is that for the specific extent that we have, it doesn't mean that all values are present. So in your legend, you actually don't need to put all the values. But how are you going to determine that? Well, first of all, here, what we're going to do is we're going to extract all the unique values from the existing land cover dataset for Sao Paulo. And then once we have those, we're going to create actually a table with all those names of those land cover classes, and then we're going to filter out only those that we need, and later on we will pass that to ggplot2 so that in our legend we don't have numbers, but we actually have the labels for each land cover class. Well, let's first of all start with the actual values in our data, and I'm going to exactly call it that way, not labels, actual values. So actual values we can fetch using values function from Terra, and we over here we just need to pass this object city land cover resample. This is what I do. And then what you also want to do here is you don't want all the values, you want the unique values. Remember, these are categorical values, and you could also even sort these values so that you can clearly see what's going on. Okay, so once you actually run this, you will see something very interesting, and that is that not all values are present here. So you will see once you print this that, for example, level 20 is not present here, as well as values 70, 95, and 100. So essentially we can simplify our legend by excluding those three labels from our legend plot. All right, so what we can do now, we can then create all the possible values that exist. So why do we do that? We do that because then we can go and filter out those that we don't need. So here we're going to create all of them by simply creating a sequence here. So from 10 to 100 with the increments of 10. And of course, that's not sufficient because we also need to append 95, which is currently not here. So we can simply use append from base R, and we will append, of course, the previously created values. We want to add 95, and we want to add after the ninth element. So after number 90, and number 90 is the ninth element in our list values. All right. Okay, so this one, values, is going to have all the possible values in the data set. Actual values is going to have only the values for the Sao Paulo extent. And then for the labels themselves, I've already actually created because I wasn't really able to fetch from the data. So I created here the labels, which you can see, for all these possible values. So from tree cover to moss. Okay, and then I'm actually going to call this simply labels, and I'm going to put this into a vector. All right, so once we actually have this, this vector, what we need to do next is we need to create here our own codebook. Which is going to be here a data frame which will have two columns. So it's going to have the value, what is called not actual values, but all the values, and then also all the labels. So values and labels, this is going to be our codebook. And then what we want to do here is we want to get only the labels together with values that exist in our dataset. So we can create here actual labels, and then we can use subset from base R, and we can subset the codebook itself because codebook has all the values. And from codebook we want to subset this values column, and we want to select only those values that are present in actual, again, labels, not labels, but actual values. Correct. So what this is going to give you, and I'm going to actually show you now after running everything, what this is going to give you is it's going to give you two columns, so values and labels. And as you can see here, we have 7 values here. all right? Because only 7 land cover classes are in that extent for Sao Paulo. All right, now that we have this, we are ready to go to ggplot2, and we are ready to use these labels with tidyterra and create some awesome land cover map for the extent of Sao Paulo. Okay, and we are finally ready to create our map. We will start off by calling here ggplot2, and then we will add our first layer with the help of a function from tidyterra, which is called geom_spat raster. Now over here, you need to specify the data. In our case, this is of course city land cover resampled. But if you pass it this way, basically ggplot2 will recognize this as continuous values, even though they're categorical. So in order to tell ggplot2 that we have land cover classes which are categorical values, we need to put here as factors. So basically we just need to coerce this into a factor. Now the second argument that I want to show you here is pretty much optional because it's by default handled by tidyterra. And it's called use call tab. Basically, in our raster file, we have a color table for each land cover class. There is a color that is attached to it. So basically, this is just telling tidyterra is telling to ggplot to grab those colors from the table and use them. If you don't want to use those and you want to specify yours, you can put here false, but then later on in the code, you will need to specify some colors. All right. And then finally here, what you can also tell optionally to tidyterra is that you're not concerned with the number of maximum cells because we're using simply here categorical values. So you can set this to infinity. So it's more or less optional. All right. And then you can add the second layer, and this is again quite optional. So this one is the SF object of the city boundary. So we need to use geom_sf. For the data, we of course here provide city_sf. And then what we want here is we want the filling of this object to be transparent so that we can see the map of the land cover. All right. But what you can choose is, for example, what is going to be the color of those boundaries. And you can go for some neutral color, like, for example, white. And you can also here choose how thick these lines are going to be. So you can go, for example, 4.5 pixels or anything else that you like. And now that we defined both layers, what you can do next is you can specify further or customize your legend. For this purpose, you can use again tidyterra, and there is a function in tidyterra which is called scale fill call tab. And this applies only in situations where, of course, your raster file has a color table, like in our case, and we also specify here that we definitely want to use this color table. So over here, what you want to actually do is you want to do several things. First of all, you want to specify here that this is your data that you will be, from which you will be pulling this information. Again, it needs to be coerced here to a factor. That's the first thing. The second thing is simply customizing some items such as, for example, legend title. I can, for example, put here land cover class. And then the second argument is, I would say, more important because over here is where we can put our labels. So we can use the actual labels data frame that we have, and then we can access the labels from it. So this is actually going to pass to the legend those labels that we previously defined. And more importantly, it's going to take only the labels that are needed. And once you do this, of course, there are many other things that you customize within your ggplot2, but I'm just going to, for now, use this theme avoid argument and get rid of any excess, material or elements around the plot. Once I run this whole thing, you should be able finally to see the land cover and the land cover classes for the extent of Sao Paulo together with the city boundaries of Sao Paulo. And this is how you leverage the power of the Microsoft Planetary Computer API through R using the ESA global land cover dataset to create this Sao Paulo land cover map. Of course, you can take this tutorial on a journey across the world, and I'm very excited what you create based on this tutorial. If, however, you're interested in replicating today's analysis, I prepared the link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your knowledge of geospatial analysis and data visualization in R, I prepared a few cool tutorials for you, so do check them out. See you next time.